So I'm just going to kind of give you guys a brief introduction into like what the graph is and like why it's important before we actually get into like live coding and workshop. Who here has heard of the graph before? Who here has actually deployed a subgraph? Anyone? A few of you guys? Cool, awesome. My name is Kevin Jones. I'm a DevRel engineer working for Edge and Node at the Graph. And I also help out with the Build Guild, obviously. I give a lot of workshops like Austin does. So I helped organize this event. We're going to talk about like what the graph is, why it's important, and then we're actually going to deploy a subgraph for that branch of Scaffold-ETH that we're using, and show you how you can do that. So the main concept of like a dApp was this kind of like initial architecture where you have a front-end application and then you have your back-end application, right? Your smart contract, and you would read data and write data from the blockchain. And I think that was like the first kind of idea for a dApp, so to speak, decentralized app. But when it comes down to it, there's some issues with reading data from the blockchain. Most blockchains are actually incentivized for writes. You know, you pay some gas into the blockchain to change state, but there is no incentivization for the blockchains to really, or the nodes to give you quick and reliable data. And the RPC is not really designed for getting lots of complex data as well, so it's very difficult. Like let's say you want to see historical data, what happened to a specific value, or if you want to make calculations on the data, like you have to make multiple calls and then do some kind of equations on that in your front end. So that can be a little bit messy to work with. And so what we see is like in the wild is something like this, where people are trying to like iterate over, like in this case, someone was trying to get all the NFTs in a wallet, and then they were basically trying to loop through those and build an object. So basically every single NFT was a call, like an ETH call. And so if you have like 10 NFTs in your wallet, it's not a big deal. But if you have hundreds or more, it could take 10 or 20 seconds for the page to load, right? Because it's actually got to go through and make all these calls, build this object, and then display it in the front end. So it's not really ideal for that. And this is actually code we saw in the wild, which is crazy. So what we actually want to do is, sorry, I'm going to kind of piece through some of these slides. We actually want to take this kind of mess of data that we have with the blockchain, and we want to organize it and make it easy to consume. And the way that we can do that is by listening to smart contract events. So every good smart contract programmer writes events. You guys learned about events a little bit previously in the previous talk. And so these events give information that you would normally want to consume in your front end. And this is perfect for what the graph does because we can index that event data. So what is the graph? So the graph is a decentralized network. It's a decentralized network of indexers that are running the stack of the graph, which we'll get into in a little bit, but it's basically graph node, which is written in Rust, and it is IPFS for like all the manifest files and stuff like that. And it's basically just and it's running Postgres as well, which is like for storing the data. And it just provides like a GraphQL layer for that data, right? So this is kind of like live footage of what the graph does in production. As you can see, it just kind of goes through and organizes a mess into these little buckets that we call subgraphs. So what we want to do is something actually like this, where we still have our front end, and we're still writing data using the consensus layer of the blockchain, because that's what the security is for. But then we're reading data directly from the graph. So it's kind of like a middleware layer, right? And that's where the graph fits in. And it gives you a GraphQL API. So what we're able to do is like take that messy little like thing that we were doing earlier and consolidate it into a GraphQL query. If you're not familiar with GraphQL, this is what a query looks like. It's very basic, but it will allow you to specifically query for what you want to get back and get in your front end. So in this case, we can say, well, we want to get all the NFTs of a specific owner, pass that as a string into the request, and then we can actually get back all the detailed information like the ID, the token ID, the metadata, and we can also get all the previous owners, which is great because we can keep track of that stuff. And this is all done using GraphQL and Postgres, and it basically does all the work for you. So I think that's a good, at least basic introduction to the graph. I'm not going to go the full spiel on the graph. I'd rather that we get started and kind of start coding. What I did is earlier, like last week, I took the Scaffold-Base package and I basically, Scaffold-ETH is a mono repo, right? It has multiple packages. I just added an additional package and I uploaded it to my GitHub. So if you guys, just for ease of access, you can go to my GitHub. It's kmjones1979. And you can go to, if you wanted to go through this, you could. Go to my repositories. And then it's one of the last ones that I uploaded right here, Scaffold-Base, the graph. So it's basically the Scaffold-Base package, but it also has an additional package for the graph called subgraph right here. So it's still got Hardhat, it's got Next.js, but it's also got this subgraph package. So I'm going to use this. So just so you know, if you want to follow along, you're going to want to use that one. Okay, so here I have multiple terminals up. I think if you saw Austin earlier do his demo, you always need a few windows open with Scaffold-ETH because you need one for deploying your front end, one for deploying your back end, one for actually deploying the commands. And in this case, we want to use a fourth one because we're going to use the graph running in Docker. Okay, so you don't need to use the Docker version. You can also create a subgraph using just the subgraph studio. But I just want to show it off so you guys know how it works. And also there's, just so you know too, there is another branch of Scaffold-ETH, and it's going to eventually be into the main command of npx, where you'll be able to run this npx command, and it will say, do you want to use the graph? And you'll say yes. Right now it's not there yet, but it's going to be there soon. But in the meantime, if you just wanted to use Scaffold-ETH, there's also another branch here called the subgraph package that also has, if you didn't want to use Scaffold-Base and you wanted to use Scaffold-ETH, it's right here. It's called subgraph package. So just so you know, there's a couple ways you can do it. But again, we're going to use this. We're going to use the same setup that basically Austin did, but we just have the graph set up. So let's do that. So let's do yarn chain to set up the chain. And then let's come over here and do yarn starts. So same thing. Got the back end, the front end. Then we come over here and do yarn deploy. -- reset. And we'll just deploy the contract. Let me load this up real quick and just make sure I wiped out all my changes, which I think I did. Yeah, so this is just basically after you do, I did a git reset on this, so it should be pretty good. So yeah, the first thing you'll notice is there's an additional package called subgraph. And we'll get to that in a second, but I just want to show it off. Then there is just our normal Hardhat directory and the contract. So let's just go through real quick and add that event. So I think we needed to do uint 256, public, what do we say, like value. And then we need to do the event. So it was like event incremented, I think. Yeah. And we do address, incrementer, new value. That's right. And then we needed to do a function. So we do function inc public, like that, yeah? Why is it value L? See if that's right. There we go, cool. All right, so I basically just added the incrementer right now. So you need the event called incremented, and you need the incrementer as the function that emits the event, and then you need the Boolean basically created. So we could set it, I think he had it set to 1, something like that. So let's do that, and then let's just deploy that. Oh. Okay, so if we come over here, load up Scaffold-ETH, let's take a look. Okay, so then we should have this like debug contracts tab here, and then we should have the ability to increment. Let's see if it works. I don't have enough gas. Make sure we get some gas, and then it should work. Yep. So we can see here that the value is creating. I'm not going to do all the front end stuff because I don't want to put you guys to sleep. That's like the most boring part of hacking, you're doing the front end stuff. So it's working. We have like those changes that Austin did. So first, let's take a look at, we don't have the graph set up yet. So the next thing we want to do is set up, this smart contract also came with an existing function to be able to set a greeting. So we can say here like foo and hit send, and we're able to update the greeting like Austin did earlier. And there's already a subgraph written out of the box for indexing that data. So we can take a look at it real quick and just see what it looks like. But if we come here to the subgraph folder, a subgraph is basically like 3 files that you need to understand. The first is the manifest. It's called the subgraph YAML. It's basically like the high-level kind of overview of what you care about in your smart contract. So in this case, it has the network that we want to deploy to. It has the contract address of where our contract is deployed to. It has the things like the ABI location. So if you're not familiar with ABI, ABI is basically the application binary interface. It's how your front end can interact with a smart contract. But the graph needs that as well because it needs to know what the event looks like in terms of like data types. So it references the ABI. It also references what are called handlers. So you can see right here that there's this concept of handlers. Basically, that is like what gets processed every time that an event gets fired off. So if we have an event that allows someone to update the greeting or increment a value, then we need to have a handler that then processes that data. So that's what the event handler is. And then we also have the schema, which is here as well. So you can think of the schema as like the data structure, like a database table would be. So the schema is a GraphQL term, and it's basically defines like what data types you care about and how you want to store them inside of GraphQL. And so you can see here that there's a entities section. So you can think of entities as, I guess, columns inside of a database, right? So you have the handlers, and then you have the entities of where you want to store the data when that event is handled, okay? So this is a high-level overview of just what network, and so we actually want to change this to, I think we need to do localhost here. Let's try that, because we're going to use localhost for this first demo. And then, yeah, so then let's take a look at the data types. So inside of here, we have the schema, and we have the mappings, okay? So again, the schema is how you want to store the data. So in this case, for this subgraph, we care about for the one that comes with, we care about the greeting, and then we care about the sender, like who's actually proposing the greeting. So these are 2 separate data objects, and I'll show you in a sec, but here you can see we do this thing called derived from, where you can make these like relational lookup tables for these entries. So these are actually what gets stored inside of Postgres on the graph stack. And so here we can see that there's this derived from senders. So basically every time someone sets a greeting, it will use this sender object to create a list of who that sender was, and then kind of link them together, and using that derived from. So that's really powerful. And then you can see that we, like in the greeting example, we have who the sender was. We have the string that they actually set the greeting to. And then we have like whether they paid any value, if it was a Boolean, true or false. What was the value that it was being passed? When was it created? Like basically what was the timestamp? And then what was the transaction hash? So this is all data that we get from either the blockchain or we get it from the event, right? So if we look at the event for the contract, we should see something similar for that particular one. So here it is. It's the address, the greeting, the Boolean, and the value. So it kind of matches what we see here. The ID is a generated ID that is specific to the entry. So it's like a hash, transaction hash, or sorry, it's an entry hash, ID hash, whatever you want to say. And then these are the stuff that we actually care about in storing. Okay, so subgraph YAML is the high-level overview of how everything works together. Schema is how it's actually stored inside of the database and queried from GraphQL. And then the last part is the actual handler, and this is the mappings. So this is probably the most confusing part of a subgraph, but this is written in assembly script, so it's a subset of TypeScript, so it looks very similar if you know TypeScript, but it just has a little bit limitations, like you don't have full support for TypeScript. And you can see here that we do some things like import some stuff from the GraphTS package so that we can work with integers and addresses or whatever we need. So there's a package for that, a TypeScript package. And then we can also import the contract. We import the greeting change, which is an event. It's like a type, so that we can use the types to interact and save. And we also import the schema here as the objects of where we want to store the data. And then we have this handler. So again, you can think of the handler as like an automated way that you like process data, right? As it comes off the blockchain. So in this case, we want to handle all the greetings that change, right? So we say, okay, here's the greeting change. What comes across in the greeting change is this event. And we want to basically start building out how the data should be stored. So we figure out what the string should be for the ID here. We see if we can load it. Like basically, does this sender exist already? If they do exist, we'll load it into the handler. If it doesn't exist, we'll create one basically, and we'll set a timestamp, and we'll set the greeting count to 1. So it'll be like the first time they ever set the greeting. Otherwise, we'll just increment the greeting to whatever. So it's basically, you get this logic, if else logic. And then eventually here's where we actually set what the greeting is. So here we're worried about this. We're basically doing all the logic for the sender. Here we're doing the logic for the greeting. So we say, oh, well, same thing. What is the greeting ID? And we create that using this kind of like 2 hex, and then we put in this dash and all that stuff. But this is the important part. This is where we get the data from the event. So we say, all right, well, the event has parameters, and they're called new greeting. And then we figure out what the sender string is from here. And we see if they paid a premium, what was the value. Then we can also get a block data. So here we get the event block and the timestamp. And then we get the transaction hash as well from the event and store that. And then we save this. So this part here is where it actually saves the data in Postgres on the stack. So if you're using the graph network, you don't need to run this stack, but we're just going to run it just to show how you could if you wanted to. So let's do that. So here we can do, there's a built-in function for this called yarn run node. So what this is going to allow you to do is basically spin up a Docker compose file. So you don't need to know Docker to use this setup, but it's going to go out and spin up the 3 things I mentioned earlier. So again, the graph stack is graph node, which is written in Rust. It's Postgres, and it is IPFS. And it's going to basically start kind of like running. It might take like a couple minutes to start up. You'll know that it's running when it says downloading latest blocks from Ethereum. So let's see if it actually... For some reason, it doesn't look like it's actually going. I need to check one thing actually real quick, because I think I might have put the Scaffold-E2. Yeah, it should be localhost. Okay. Well, let's try to yarn. So let's do yarn. So if we go to the Scaffold-E2 packages folder, there's a README here. So if we go to subgraph, and then there's a README here that kind of walks you through all this stuff. So if you want to use the local one, that's fine. So here we have, that walks you through how to use the subgraph package. This is not the base one. But anyways, these are all the stuff I already ran. And then let's do this, yarn clean node. That works. And yarn run node. Okay, so let's see if this works. For some reason, it doesn't look like it's running. Okay. For some reason, it's dying on me right now. Okay, we might have to do this a different way. That's okay. Let's try to do it a different way. Let's try to do this. Let's do a yarn deploy. So let's pretend we want to deploy this to Scaffold-Base. So let's see if I need to fund this. So did you guys deploy your contract to Base Scaffold, by the way? Did anyone actually do that? They just were doing it locally, right? Because I know Austin showed it, right? He showed how to deploy it. Did anyone get that far? No? Okay. Let's try to do that right now. So let's see, account, Base Scaffold, tokens. Okay, let's send this some tokens. 0.05. Okay, so basically I'm just funding my deployer account. And we're going to do it a different way, but let's do deploy -- network base Scaffold, I think. Let's see if that works. Insufficient funds. No. Did it go through? I might need to send more money. Let's try to send a little bit more. Let's do yarn account. See if we got funds here. For some reason, it's not going through. This is the right one, right? I feel like it should be a lot faster. The demo gods are not in my favor today. This always works really, really well. I might have to just deploy it to Scaffold. That's so weird. It's almost like my transaction's not going through. There it goes, confirmed, confirmed, confirmed. Come on, come on, come on. That's so weird, huh? Well, let's try one more time. Insufficient funds. Maybe I just need to send more, but yeah, it doesn't show that it's getting the funds, so. Okay, this is really weird. Okay, well, let's pretend that that part worked. So sorry that it didn't deploy. I don't know exactly what's going on with my setup. I ran into 2 demo problems for some weird reason. So anyway, so at this point, you could use this package to deploy your subgraph locally. So if this would have worked, like you would have basically seen that it would have said like, okay, connecting to your hard hat node, you would have been able to do a deploy your subgraph here and deploy it into the graph node, and you would get like a graph IQL. So GraphQL is kind of like this GraphQL Explorer. One of the benefits of using the studio, so if you go to the graph.com/studio and you go to connect wallet, basically connect your wallet, and if you deploy your subgraph to the studio, you'll get access to the GraphQL query. So like we could have an example here. This is like one I did earlier this week where I deployed it using the studio. It's a little bit of a different process. I feel like I'm having internet connection issues or something weird. Let's try it one more time.
Have you previously asked if someone deployed the contract from previous?
Yeah.
So we have Austin's contract.
You have Austin's contract. I was going to maybe use that. Yeah, it's okay. Well, I'm just going to show you like what the data looks like so that you know. But if we would have done it using this thing, we would have had like a local host browser that we could have queried the data. The next step would be that you probably want to deploy your app to a test net like I was trying to do that would work. And then you would create a subgraph on here. So the way that would work is you would go to Subgraph Studio. You'd say create a subgraph. You'd name it, Scaffold-Base or whatever, create subgraph. And it will kind of like scaffold you out an empty subgraph. And it will walk you through all the commands that you need to run to be able to create a subgraph. So all that stuff that I showed you, like the manifest, the schema, and the handlers, will already be generated for you when you run these commands. So the first step is to install the Graph CLI. So you can use npm or you can use yarn to do that. And then the next step is to initiate a directory. So in this case, it would be graph init Scaffold-Base. And then it's going to ask you to authenticate against the CLI using this Graph CLI. And then go into that directory, run a code gen, which it will actually generate all that code that I showed you. And then run a build, and it will build the WASM module. So something I didn't mention earlier is that the assembly script is basically compiled down into WASM, and that's what the indexers run. So that's what keeps it secure and safe from any kind of like malicious actor running. And then you then deploy using that last command. So we can look again and see. I won't go through the whole thing just for the sake of time, but if we go to Subgraph Studio, and then we go to, let's just see if this one, oh, here we go, your contract tests. Oh, it's simple NFT. These are all archived. Let's try this one. So this is like an ERC20 NFT, ERC20, sorry. So this is an example that I already deployed. You can see here that it's completely synced, and it's at 100%. And you have this Graph IQ, or basically this like GraphQL Explorer here, where you can pass in the GraphQL query language and then get back a data structure. So in this case, we have all the approvals for a particular NFT. So this is like, actually, this is an ERC 721. So these are NFT IDs, and these are the who approved it. And then there's like the token ID and stuff like that. And then there's also this option here where you can, it's hard to see on the screen, but there's this little kind of explorer. And you can build out a custom sub query by just selecting what you want. So like, let's say we want to get transfers, and we want to get like the first, 10 transfers. We want to order it by the timestamp. We want to do order descending direction, and we want to get the to, the from, and the ID, and maybe the timestamp, and like the token ID, and then hit play. And it will give us that exact information that we query for. So, and then it'll build it out for you. So that's kind of the power here is like, everything I was trying to get to is like, you don't want to really listen to events on a smart contract just using Ethereum JSON RPC. You really want to do something like this where you're able to, query the blockchain directly. Query the data directly just with one GraphQL API and not have to worry about querying the blockchain. Does that make sense? Yeah? Okay. Yeah, so it's pretty easy to get started on the graph. If you have questions, I'm going to be around. You can let me know.